All right, welcome everybody. I'll be talking tonight about animation in SDL Perl, but first, a cautionary tale. As I had said in my email, I didn't start this presentation until just like last weekend, so I've been frantically working on it all week. And then last night, I was developing it on a different box, so I'm like, well, I better put it on the laptop, make sure it works, and I'll just hook it up to my TV so it's like real life and give it a test. Well, as I'm starting to do that, all of a sudden my machine just slows to a crawl. Like, oh great. And I was saving my VirtualBox Linux session and I'm running Windows 7. And long story short, I waited about 15 minutes for the thing to shut down and I ended up having to do the power thing. Bring it back up, go to VirtualBox, unavailable. Crap! Windows 8 my presentation. So anyway, luckily it was just the VirtualBox configuration and the actual VirtualBox disk was okay, so I was able to rebuild another virtual machine. And anyways, long story short. So if I ever come in and say, Windows 8 my homework, you know that's actually a possibility. It's true. So okay.
You didn't have a good experience with Windows 8.
Oh, well, this is Windows, yeah. Okay. Also, because I didn't come up with a title for the presentation, a good one, beforehand, I gave you a bunch of bad ones. So enjoy the horrible, horrible titles. Okay, so previously on SDL, I'm just going to go over briefly what I talked about last time. What SDL is, what Perl is, hopefully you know that. What is SDL Perl? Hopefully telling you how to install it, talking about surfaces. Those are the things you draw on. Then we had some examples. Woohoo! That was your 30-second recap of what I talked about last time. And here's a link to the video. I feel really bad for you guys. I hate listening to myself. It's like, is that what I really sound like? So anyway, just links to the previous stuff in case you want to see what we talked about last time. Okay, what I'll be talking about tonight is the SDLX modules. So the SDL modules just interface with the SDL libraries. And so they're relatively low level and just give you access to, basic things like drawing primitives, certain shapes and things like that, copying images around from different surfaces, polling event queues and things like that. But it's all pretty low level stuff and, some of it's kind of tedious. So some wonderful people on the internet came up with the SDLX stuff, which gives you a higher level abstraction, which takes care of a lot of the busy work so that you can just concentrate on what you're actually trying to do. One other thing I don't think I talked about last time, but this is really nice, is they've actually got a manual here that was part of a grant, I think, that somebody got from the Perl Foundation. So they've actually got some examples like a Tetris game in Perl, which works for the most part. I noticed a couple of buggy things that weren't quite being checked for, but they also have a Pong game in there too that they just walk you through the code. So it's actually a really good tutorial. Just to show you the difference between the two. Is that good for everybody? All right. This is like the last example I gave on the last talk. So it's basically bringing in our modules. We've got SDLX. Hang on here. Oh, okay. Yeah, I remember. With this one, they're using just SDLX app, but they're not actually using any of the functionality. So they're still doing all this stuff low level. So like here, you're pulling for events in a while loop, and you're just saying, if I get a type of quit, then quit out of it. I'm not really expecting you guys to pick up a whole lot from this code. I mostly want to just show you the differences between using the SDLX stuff and doing the low-level stuff. So then you've got to do all your calculations and your rendering and drawing of rectangles and all that stuff. They've also got some frame rate calculation stuff that's going on here. And again, this was, if you want a better explanation of that, you can go watch the YouTube video where I actually kind of talked about what I did. So this one is actually does the same thing. It just, by the way, it just shoots a red laser across the screen. So I'm not even going to bother running it. If you want to see that, again, watch the YouTube video. I ran it last time. So what's going on here with the SDLX is now we're actually just using the app and we're just adding an event handler. So instead of polling the event queue, we just add a handler, and you can actually add multiple handlers and they get called in the order that you added them. But in this case, we've just got one, a move handler and a show handler, which if you think about, a game, that's the basic structure is, watch for events. What is the user doing? Or, pushing a joystick button, moving a mouse, clicking, pushing a key on the keyboard. Then the move is, recalculating everything. Guy jumped from this position to this other position on the screen. So calculate that out, what that looks like. And then the show handler is just what actually renders it on the screen, so you can actually see what's going on. And then you just call app run, and it's got its own event loop that it just goes off and starts waiting for events and just running through all of these things. And then when it gets the events, it calls your event handler. So you can tell this one doesn't do much interesting. It just is, again, looking for the quit, just like the other program did. But it's just, you can tell there's a lot less code here. Does the laser calculation, does the rendering. That's it. This program does the same thing as the other one did, minus the stuff about the frame rate calculations. So that's about it. I just wanted to show you what you gain by using this. So what I'm actually going to show you now is what Windows Almost 8 and I spent all week working on. And you could tell I couldn't come up with a clever name for the presentation nor the actual program, game.pl. That's pretty lame. But anyway, so at this point, it's not actually a game yet. I wanted to get a little further than I did with it, but I figured this is something I'll probably build on, and I can give more presentations as I go, as I add more features to it. So right now, what it does is obviously renders a spaceship on the screen. Believe it or not, this is the same Sprite that I used. There's a free Sprite library that has been around forever, because I started on this in C like 15 years ago. So I just took that Sprite, scaled it up 3 times, because back 15 years ago, really small Sprite was fine, but yeah, didn't look so great here. So if I hold down the left and right arrow keys, it rotates. If I press the, one thing that is nice here is if you hold the key down, you can bump it or hold it down. I didn't get time to do that with the increasing power, so up and down are increasing power, decreasing. And you've got 10 power levels. Once you get past 5, you notice you've got more fire, because it's going faster. See, and then the physicist had to leave. I knew, I'm sitting here gonna be violating the laws of physics, and he's not even here to heckle me. So anyways, it's got 10 levels. 0 looks like that. Anything between 1 and 4 looks like that. And then anything higher, you get the full animation. And again, it renders correctly as you're spinning around. So, nothing great as far as what you would expect from a modern game. But consider that I had zero code starting last weekend, and when you see how little code I actually have, you might be a little bit more impressed. So anyways, and then you can press Q or escape or whatever to quit. Some of the things I wanted to do in my old C version, I had, it was actually two-dimensional, but it looked like, you know, parallax scrolling of different levels of stars and stuff like that. Didn't get a chance to get that in, but that'll be in next time. And also sound effects I didn't get to, but I figure that's a good topic for another time. So let's look at, now that we've seen what it does, let's look at actually how it does it. And I'm getting horrible signal interference there. Okay. All right, this good for everybody? Everybody can read that? All right. Okay, the first thing I do, I don't know how many of you like to do this, but especially for stuff like this, I like to use constants just because it's nice to look at something. And also it's nice because this rotation step, I originally had set at 10, and then I realized that, you know, you hold down on it and it's like going, you know, it was way too fast. So it was nice to just go to one place and change the constant, and there you go. Now it works at a better speed. So we're pulling in all of our SDL modules, our lower level, and our SDLX app. We're using ship, which I'll show you in a little bit. That's got all the code for the ship. And actually, I tried to hide as much ugliness as possible in the ship code so that the game code is nice and clean. And I'll show you how I did that in just a little bit. So I just set up my height, width, color depth 32, title, game. I got to come up with a better name. Also exit on quit, so I don't even need a quit handler. It's actually got one built in. All I've got to do is pass in that flag to say exit on quit, which a quit event is like clicking the X, is what that is. If you want to quit with a key, I'll show you how I do that in a different spot. But that at least handles, because literally if you run one of these and you don't have a quit handler, you can click on that X all you want and it's not going to go away because it's just ignoring that event. So then again, okay, so I create a new ship and then I pass it the app, and you'll see why in a little bit. It needs that information. And then I just set up my handlers and run, just like the other program we just looked at. The event, the move, and the show handler. So I'll just show you each one of those in turn. Okay, SDL libraries give you a lot of nice constants as well, so you don't have to, you know, look at the ugly integers these things actually represent. So it's just, it gets the event and it gets the app, which, remember, the app is also a surface, so it's basically the window, the screen that it's working with. But it's a subclass of SDL surface, so you can treat it just like a surface and do everything you can with a surface. So I just ask it to give me the key symbol, and I'm just doing, you notice I'm actually doing an actual AND instead of the normal AND you're probably more used to, because these all represent integers, and you can just tell off of that, hey, is it one of these? And if it was any other one, you can quickly exit the loop, because you don't want to spend a lot of time in your handler trying to handle a key that does nothing in your game. So that's why I just checked for that. Oh, I skipped over key down. So basically you have key down and key up events are separate events, and you'll see why that's kind of handy in a minute, because I'm about to that. So if it's left or right, I rotate it, and you notice my rotation step, you remember that was a constant of 5. Basically that's 5 degrees, because this is all measured in degrees, not radians or anything like that. So I basically, if it's right, I pass it a -5. If it's left, I pass it a +5. And that just, I'm using this for two purposes. One, to store how much I'm going to move it by, But another, I'm also just using it as a flag to say, hey, am I supposed to rotate? And you'll see why again later on when I get to that. And then the up and down key, basically, I'm sure this looks like it makes sense. You take whatever your current velocity is, add 1 to it, and store it back in velocity. And again, this is why I can't hold the keys down, is because I'm doing the calculation here, whereas these I'm passing in a value and doing the calculation elsewhere. So that's one of the improvements I'll make, is so you can hold the up and down key. And here is what I mentioned earlier. If you want to do your handling to quit off of some key combination, you can actually get a key name, which then gives you the actual character. So you can match it off of a regular expression. So I'm basically just saying, if I get uppercase or lowercase q, either one, quit. Or if I get an escape, then quit. So I hate any kind of program where you get in and you can't figure out what key to hit to quit. So I added all kinds in there. So you got like 4 ways to quit. So any way you want. All right, now we'll get to the key up. And there's not nearly as much going on here, but basically all I'm doing is this is for the left and right. When you're holding the key down, you get the key down. Then when you let go of it, I set rotate to 0. So that means, you remember I said I was using it as a dual purpose. Now it's a flag that's set to 0 saying, oh yeah, don't rotate anymore. You know, the user let go of the key, don't rotate. So any questions so far? I probably should have stopped earlier and asked. Okay. Stop me if you do have any questions. Okay, calculate positions. So you can tell here there's still not a whole lot going on because I shoved as much of the ugliness away as I possibly could. So if shift rotate, you remember it's either going to be 0 if they haven't pressed a key, or if they've released the left or right key, or it's going to be positive or -5, which in Perl, either one of those is true. So that way I can just use it as a flag. And then I actually set the rotation of the ship to whatever that value is, -5 or +5. So I basically take whatever the current rotation is and add 5 to it or subtract 5 from it, and then store it back. And then I call update, which this is, I'll tell you right now, spoiler alert, this is where most of the ugliness is, because it goes through and does a whole bunch of calculations based off of whatever the user has done. It's got several things it's got to figure out, and I'll explain that all when I get to it. Okay, any questions with that? Okay, if not, the last thing, update screen. Literally here, and this is kind of sort of cheating, and I should optimize this better, because I'm literally just clearing the whole window, which, you know, is highly inefficient for one thing that's on there. Once I get the stars and stuff in there, you know, then I have to weigh whether it's, you know, faster to just clear the whole screen, or is it faster to go through and, you know, clear each individual part before you render it again. But it's actually surprisingly fast. Remember, this is actually, we're running in a virtual machine here, and the animation is, you know, really smooth. I haven't run into any issues yet. Now, obviously, I've just got one object on the screen. We'll see whether or not that continues to be that smooth once I start doing more interesting things with it. So I'm basically clearing the screen. Then I'm asking the ship, what is your current sprite? Because we've got basically 3 sprites in there. We've got the one with no power, the one with medium power, and the one with full power. And those are the ones we just rotate to get the flashing fire effect. So I just asked the ship, which one am I supposed to use now? And the ship tells me, and then I draw it on the app surface, and then I just call update, and that's what actually refreshes the screen.
Do you have to do anything special to handle frame rate or time?
No, that's the nice thing, is that, yeah, this is handling it for you, and it's actually handling it based on fixed time. So, I've run this on, actual Linux boxes and my virtual machine, and it runs the same. The animation doesn't, wig out, or it doesn't spin fast or anything like that. So,
does it support a variable time step? Or do you know?
That I don't know, because I haven't dug into the code, but that's a good question. And if I get some time, I'll look into that and maybe send that to the list, or if I remember, maybe I'll put it into the next presentation.
Or
If I dig
the
into
fact
it.
That it's handled already, that you could speed it up with your own logic, if you had specific things you wanted to change. Change the speed at which somebody moves across the screen or whatever.
Yeah, well, and the other option you obviously have too is you can always drop down to the lower level libraries and do whatever you want. If you've got something, this is just basically a lot of convenience. So if it doesn't give you the performance you need, you can always opt to use the lower level libraries. Okay, any other questions on this? So again, it's basically really, this is it. If you're, just compartmentalizing all this logic, that's the whole thing. Not much to it. Okay, so the ship has a little bit more to it because, like I said, this is where I hid some of the ugliness. Right now, I'm not actually using all of these constants. I ended up setting some. Hopefully that line will go away.
Increase the font one. That helped last time.
Ah, there you go. That's weird. All right. So I'm not actually using these, but I probably will in the future. I am using the max velocity. Oh, actually, you know what? I am using the no power. I'm not using the other two, but I figured I might eventually, so I just added those in there. Basically, these are just the frame indexes, 0, 1, and 2 for the 3 that we've got. And the max velocity, like I told you earlier when I was running it, is 10. And obviously, I could just change that if I wanted to. So I just set up a few variables, tell it to use SDLX Sprite. Now again, this is one of the SDLX modules, which gives you a lot of convenience compared to blitting all of these things yourself and all of the housekeeping work that's associated with that. It also gives you rotation, which obviously I'm using in this demonstration. That was actually part of the reason that I decided to kind of go with, a ship that's centered, to rotate, just because I thought that was kind of cool. I also didn't want to just totally rip off the guys who did the tutorial manual and, like do Tetris or Pong or something, because those, especially the Pong part, they can get away with a lot of it. They don't even actually use sprites. They just draw rectangles and squares and stuff like that. You don't even need actual sprites for that. So anyways, not much interesting here and new, except maybe initialize. So we call initialize. I'm going to skip over create mutator because I've beat that to death. This is just basically my automated way of creating a bunch of mutators that just need to, set and get things. It doesn't do anything else with stuff. So I set my 3. Oh, you know what? Yeah, I just found, I don't need these up here, by the way. I just noticed that. So those can go away. I was trying to do something else earlier with it because guess what? I'm doing my variables here, so those are completely useless. So I'll take those out. Anyway, I just gave these names again to make it more clear to me which one is which, so I don't always have to go off the index number. Sometimes it's convenient to do it by name, sometimes it's convenient to do it by index number. So I just figured I'd name them all, and then I just set up the Sprite attribute that has an array of all these Sprite objects. So far, makes sense? So this is no power, half power, full power.
And then the indexes.
And the indexes exactly are how I get into which one I'm actually going to display. So this is where I said, oh yeah, I did use this one once. So again, I'm initializing, so I'm setting power to the no power sprite, because we're starting the game. Velocity is 0, rotation is 0, And then I call update because, again, you remember I said earlier in the other part of the program, that's where it actually does all the calculations based off of the current information that it has about the ship object. Okay, again, create mutator, that's magic. Let's not worry about that. Okay, velocity, yes. This is basically, all I'm doing here is if you're passing in a new value for velocity, I'm doing something with it. Otherwise, in both cases, if you pass something in or if you just call it with no parameters, you're going to get whatever the current velocity is set at. Okay, so let's look at what's going on in here. I just take whatever value you put. I ignore everything else after that. And I'm just checking. I just want to keep my velocity same, right? It's got to be between 0 and 10. I guess if I wanted the ship to go backwards, I could have negative velocities, but I'm not allowing that right now. So I'm just saying if it's less than 0, make it 0. And if it's greater than max velocity, which you remember was 10, then set it to 10. So that just keeps it within a sane value. And that's all I'm doing. Otherwise, it's mostly just a setter and a getter. Rotation, virtually the same. Basically, I'm just doing some sanity calculations here to keep it between 0 and 360, just so. I actually discovered, though, it does actually work if you pass it negative numbers and numbers larger than 360. It does the right thing, but just for ease of debugging, and I don't know, just because I felt like it was cleaner, I keep everything between 360 and 0. So far, so good? All right. What's that?
It's 360 and not 2 pi.
Yes, 360 and not 2 pi. All right, current sprite. You remember that was in the draw handler where I just asked the ship, hey, ship, what's the current sprite I should draw on the screen? And this is where it decides which one it should give you. So basically, it's checking. You can either pass it in a new sprite number, which we use later to update that sprite, or if you don't pass it in, you're just going to get, you remember our sprite attribute is a reference to an array of our current sprite index, which is just one of the magical mutators that just takes the number, stores it, and gives it back to you. It doesn't do anything else, just keeps track of it. I suppose if I wanted, I could do a sanity check to make sure you're not going negative or exceeding the length of the array, but I don't know, I guess I decided that wasn't worth the effort. So does that make sense so far? So basically, you're passing in a number, but you're getting back a sprite object, is what you're getting from this. Okay, now we're to the actual meat and potatoes here, which actually I'm going to end up finishing up early for a change. Usually I'm much more long-winded. Update. Basically, here we go. Current sprite index. I just wanted to shorten that because I end up using it a lot, so I just put it into my variable. And I'm checking my velocity. If, again, oh, actually, you know what? I think this can go away too. I forgot. I moved some code around, and I just realized I don't need to do this velocity check here because I've already got velocity making sure that it's not less than 0. So actually, this can go away too. This is what happens when you try to get code done on a deadline. Dang it. So anyways, I'll try to remember to take that out as well because that's not doing anything interesting anymore. All right. So if the velocity is 0, means the ship's not moving, right? So the sprite that I want to get back every single time is the first sprite, the one that's got no fire coming out of the engines. Boom, that's it. So I set the index to no power ship sprite. And I'll explain later what happens to all of that. The next thing that I check is, like I said, if the velocity is greater than 0, and less than, this is currently 5, but I'm literally just saying half, because who knows, I may someday decide I want the max velocity to be 20, and then it'll be, 1 to 10 will give you half power, and then, again, it's just the animation that I want to give you the sense of I'm going, at a slow rate of speed or a faster rate of speed. You'll also actually, once I get the stars in there, that will also give the user that feedback, because the stars will actually move faster or slower depending on the actual velocity you're going at. But in this case, I've only got 3 sprites to work with, so it's not like, if I wanted to, I guess I could do my own sprites and have a different one for every speed level, but that's probably a little excessive anyway. So, everybody with me so far? So far, so good? All right. So, again, this is my sanity checking that I'm doing here, or actually not sanity checking, but I'm restricting this to 0 and 1, because this is when you're going at quote unquote half speed or slower speed, right? So I want to alternate between sprite 0, which is the first one, which has no fire, and sprite 1, which has the half fire coming out. Does that make sense so far? So it just alternates between those two, and that's what gives you the flickering effect of the fire. And I'll probably go back and, actually maybe this is a good time just to run it again, just so I don't have to do hand waving. So this is, you still got a little glow there of the engines, but no actual fire. So you see the flickering effect that you get, that's from alternating between those two. No fire and half fire, no fire, half fire. Just sits there and alternates. And that's all that the mod is doing, is saying that go ahead and keep adding to this, but it's got to be, the actual result's got to be 0, 1.
So
That's
is
it.
there an update screen between each one of those?
Yes. So, all right. Oh,
Is that
you know,
clear all the sprite? That clears the sprite, and then we
actually, I'm clearing the whole screen.
Yeah.
Yeah. Uh-huh. And yeah, that's a good point, is if I were, doing this like an actual professional, I would just be clearing the actual area that's, but part of it was I didn't have much time, and part of it was too, I didn't want to get bogged down in all the little details, because most of the time too, I've got my sprites as 3 separate files. Most of the time that's not how sprites are actually done. They're usually all in one file, and you just cut them out. The program just grabs, based on the size of the sprite, just grabs whatever it needs out of this giant sprite sheet. So, but again, I didn't want to put in the extra math that, didn't accomplish that much more, because I'm not trying to do anything professional here. But see there, you can see now, you get the nicer flickering effect because I'm rotating through all 3. And actually, you know what? I'll actually bring up the actual sprites too. I should do that. Let's see. I think that'll give it to me. Okay, so you can see this one, and you can also see the other thing. Oh, I'm glad I thought to do this because I forgot to mention it, is SDL is handling the transparency for me. I'm not even doing anything. These are just pings. I took, a lot of times, and maybe still people do this, but I've seen with the sprite sheets that the background's like this bright pink color. And basically they're using that as an indicator. That's the index for transparency. So you can't actually use that color in anything you want to be non-transparent. So this one, I can't remember it. Actually, I think the background was black, but and it was a PCX, does that sound right? Okay, thank you. PCX file. So I just took it into GIMP, sized it up 3 sizes larger, and just cut all the black out and turned it transparent, and boom, it works. I don't have to do anything magical to it. All right, so this is 0, this is 1. You can see we've got a little more fire going on there. And this is 2. You can see the fire goes almost all the way down. Yeah. So hopefully that gives you a little better example too, looking at the individual sprites. I'm just loading those in and it's just rotating between them. All right. So here I'm doing the same thing with the mod, but guess what? Now I'm actually allowing all 3. So I keep adding 1 to it, but the answer is always going to come out to be 0, 1, or 2, that's fine because that's all the sprites I have. All right, now this is all the ugliness that I was talking about that I was hiding. Now we actually get to the ugliness and the stuff that's actually doing a lot of the work. So we set our current sprite index to our sprite index, which, you know what? That's not doing anything either. I'm finding all kinds of, I'm going to optimize the heck out of this code when I take out all the stuff that I don't need anymore. Okay, current sprite rotation. Now, what I'm actually doing here is calling rotation. There are 2 different rotations, and maybe I should have named mine a little differently so it's less confusing, because I just realized now it might be a little confusing. This is actually setting the rotation on the sprite object, the SDLX sprite object. This is the ship's rotation, the ship object's rotation. I just realized I probably should name them differently so you don't get confused as to which is which. 2 different methods from 2 different objects with the same name, probably not a great idea. So, hey, this is, I think, one of my first presentations where I've showed you a whole bunch of things not to do. So anyways, you can tell I did this in a real hurry. Usually I try to clean this stuff up. So, all it's saying is, give me the ship's internal version of its rotation and actually rotate the sprite. So it actually takes it and just physically rotates it. Now what this means, obviously, is if you've got a ship that's like this big, you know, it's wider than it is tall, right? Well, if you take it and rotate it, let's just say 45 degrees, guess what? Now it's basically a square shape. So now it's slightly less wide, but it's taller, right? I've literally changed the shape of the sprite. So I've got to keep that, I've got to take that into account when I do my calculations. And that's what this stuff is taking care of, is all of that yuckiness.
Especially if you wanted to do collision detection, like with the edge of the screen.
Exactly. So here, with sprites and screens, you guys are probably used to this, even if you haven't done any graphics programming. Upper left-hand corner is 0, 0, right? Well, I'm dealing with stuff that's centered, right? You know, I don't care about upper left-hand corners. I want the center of the ship and I want the center of the screen. So that's what I'm doing here, is saying that the center of the ship, the X value I want, is taking the half of the width of the screen, right, which gives me the center of the screen, and half of the width of the sprite, and I'm subtracting that out so that I get to that X value that I want. I do the same thing with the Y, only it's the height rather than the width. Does that make sense to everybody? I want to match the sprite center with the center of the screen. And again, the reason why I have to do this, and I call update every time, is because you remember, as it gets rotated, the sprite is changing shape. So that X and Y value have to be recalculated every time, because I don't know if it's just sitting there, obviously it's not changing, but if the user has rotated it, then I need to recalculate where that center point is to keep the ship in there. It was actually pretty amusing. Maybe I should have kept that version of the program. Before I was doing this math correctly, as I would rotate, it would jump from being centered to then, spiraling around the, top left-hand corner of the sprite because it wasn't calculating the center correctly.
He was rotating it around the top left corner.
Top left corner instead of the middle, exactly.
Comment that out and write it, or
What's that?
you just comment that out and write it?
Yeah, well, so yeah, that's basically what I'm compensating for. And again, since every time it rotates, I've got a different size sprite, I got to recalculate that every time. And that's why I just put this all in an update, so I could just, in the game, just say ship. I very much wanted to have a ship object where I'm literally just saying, I don't care, ship, you figure it out. You figure out which sprite I'm supposed to use, you figure out which angle I'm at, and you figure out where your center is and where you're supposed to be on the screen. Oh yeah, you remember earlier I promised to explain why I needed to pass in app. This is why, because in order to figure out where the center point of the screen is, I need a screen object. So that's why I pass it into the ship. Ship does all the ugliness of figuring all that out, but it allows me to keep my game code very clean, and it's very simple to follow along with. All right. Then I basically this is where I'm setting the actual X and Y value on the actual sprite object. So actually, after I calculate it, I just pass those values into the sprite objects so that they know where they're supposed to be on the screen, right? So I've calculated the center, and the center of the screen, and then I'm just telling the sprite, that's where you're supposed to be. Go. And that's basically it, unless anybody has any questions.
So does this library have any three-dimensional stuff in it?
Actually, I do know that it has an OpenGL, SDL and OpenGL can work together. I haven't actually done any of that, so I don't know how it works. I also don't know how high level the SGL stuff is in comparison to this. But you raise a good question. I do know it's at least possible. Yeah, exactly. So
Then you could rotate it. Make a three-dimensional model of the ship and rotate it in space.
there you go. Actually, there you go. You can you can do that presentation. It sounds like a wonderful idea. All right. Well, if there are no more questions, then I guess we're finished. Thanks for coming, everyone.